Hi, I'm Andy Weinberg with Miller Welders. Today we're at PRO-FABrication talking about some of the advanced welding techniques for stainless steel.
I am Steve Sousley, owner of PRO-FABrication and makers of world-class exhaust systems in titanium, Inconel, and stainless. Here today we are going to be talking about how to weld in tight spaces and the advancements in the welding technology that has enabled us to do that.
The machines that we're using here at PRO-FABrication are typically the Dynasties and the MaxStars. Both of those have a similar inverter engine in it. The inverter engine in these machines allow you to have a real tight, defined DC arc. As opposed to years ago, standard technology was the regular transformer rectifier welding machine. Those machines had a hard time making DC smooth at those real low amperage levels. With an inverter engine, the DC is perfectly smooth whether you're welding at 1 amp or whether you're welding at 200 amps.
So one of the issues that we run into here is we are welding with extremely thin wall materials, and we have to have good arc stability here. One of the ways that we do that is we use the pulsing feature of the Miller welding equipment. Originally we started off with the pulsing welding equipment purely as a timing device to make our welds look really well. And at that point in time, the frequency or the pulses per second that the machines were capable of were somewhere in the 50 to 100 pulses per second. When we're using them as a timing device, we're under 1 second or right around 1 second pulses per second. 0.9, 1, 1.2 pulses per second. That is an ideal timing device when you're feeding rod in using the TIG process.
But with the new technology, the inverter engines allow you to get into those much higher pulse rates. Those higher pulse rates will add much tighter arc definition and still give you proper penetration without overheating the weld piece.
And here's where the latest technology really does help shine. We're now using that feature in the 200 to 300 pulse per second range.
Let's talk a little bit about pulsar settings. There are 4 parameters you need to adjust when working with the pulsar. There's peak amperage, which is controlled by the main amperage control of the machine. There's pulses per second, which is how many pulses within 1 second. And there's peak time, which is how long you are set at that high amperage level. And there's background amperage, which is the amperage the machine falls back to on the background setting of that pulse. So within each pulse, the machine will cycle through a peak amperage for a peak amount of time. It'll fall down to a background amperage for the remaining pulse time. And it'll do that for however many pulses per second you have set. So if this is 1 pulse per second, every second I have, for in this example, the machine's going to pulse from 0 to 100 amps. It's going to be at that pulse peak setting for approximately 50% in this case. It's going to drop down to a background amperage of approximately 30%, which 30% of 100 is 30 amps, and it's going to do that for the remaining half second. Then it's going to start that cycle all over again. 100, 30 amps, 100, 30 amps, 1 cycle per second. This is an example of a real slow pulse per second. This would be used for more of your bead aesthetics and reduced heat input to the piece. Every time the machine pulses to the high amperage, you're going to add your filler metal. Every time it's pulsing to the lower side, you're moving the torch over. High, add the filler, low, move the torch. If you're looking for more of a tight bead definition with more ripples and a little bit deeper penetration without losing that arc focus, you're going to increase your pulses per second and you're going to bump that up into the 200 to 300 range. You're still going to get the advantages of reduced heat input, which is going to reduce your warpage, but you're still going to maintain that penetration. However, you're not going to be able to follow it by adding the filler metal that fast. You will still deposit the filler metal in your normal application, but the pulsing action of the machine is going to give you that ripple count. When working with the pulsar, you may have to adjust your welding parameters to get the weld bead effect you're looking for. For example, in this case, I'm initially welding at about 60 amps. I have my pulses per second at 200, which will give me a fairly fine weld bead definition. and my peak time is at 40%. If I feel like I need more power to the weld, I can adjust that two different ways. I can either go back to your main amperage and increase the main amperage, or I could adjust my peak time, which is how much time I'm spending at that peak setting. Both of those adjustments will give me more average heat to the weld piece. Here would be a good example of a slow pulse setting, typically used for manually applying the filler metal and getting that consistent bead profile. For my material I'm working with, I'm going to set my main amperage at 80 amps. My pulses per second is going to be set right around 1. Anywhere from 0.9 to 1.2 is typical for this type of manual application. My peak time is going to be set around 50%. That gives me enough time to add the filler metal to the weld puddle at the high side of the pulse. My background setting is going to be anywhere from 20 to 30%. That's a low enough side to give enough cooling to the bead and reduce the total heat going into the part. Now, an example of a fast pulse setting could simply be just increasing your pulses per second. If I'm looking for a much tighter bead profile and more arc control, I'm just going to take my pulses per second and increase it up into the 200 to 300 range. Now you can adjust your peak time and your background amperage to get the weld bead effect you're looking for. Sometimes adjusting one setting will have a similar effect as adjusting another. You may need to experiment and find what's best for your application.
One of the ways to ensure arc stability is with a precision tungsten grinder. A precision tungsten grinder will use a diamond wheel, and the diamond wheel will allow a better finish and a smoother finish on the tungsten, which will ensure arc stability.
One of the areas that we see people struggle with sometimes is something as simple as tacking. It seems like when someone goes to tack two parts together, especially in a butt weld application, when they hit the foot pedal, sometimes the material will want to pull away instead of pull together. What do you use, or how do you tack your parts together here?
Well, one of the keys here is that fit up aspect that we spoke of earlier. You really have to have a really good fit. And if you have a good fit, you can do what we call here flash tacking. And by doing flash tacking, you're going to typically set your amperage on your machine to 2 to 2.5 times what your normal welding amperage would be. And with that, you just give it the pedal a quick flip and hold your tungsten in place, hold your parts together either by hand or by clamping, and you'll have a nice perfect tack.
So that basically it's a hot tack, but it's at such a small time frame, it gives the parts enough penetration to hold them together without giving you a real wide tack or putting too much heat into the piece, which causes that tack to sometimes spread apart and not fuse together.
And that's correct. This is an integral part of the exhaust systems here at PRO-FABrication. This is called a merge collector. We are challenged in a couple of areas here. We have a tight area right here where we need to have little penetration, and as we proceed down this weld joint, we need to turn it into full penetration for the integrity of this part.
Thanks, Steve, for letting us come out to PRO-FABrication to talk about stainless welding techniques. If you missed our basic stainless video, check out our YouTube channel.
For more racing, customizing, and restoring tips, go to millerwelds.com.